I am very tired today, I admit it. So, at 5 a.m. this morning, I don't know if this has happened to anybody. Probably it has happened to some people before. At 5 a.m. this morning, I kind of woke up like this in my bed, and I heard a sound like, and my cat was vomiting. Yeah. So I had to get up and clean the vomit. But I couldn't fall back asleep after I cleaned the vomit, because I'm thinking like, oh, I have to wake up in 2 hours. Anyways, so I'm sleepy today. Any questions before we get started? So I just uploaded this QR code for Friday workshop attendance. So if you want to record your attendance, you scan that QR code. And I think I need to delete this one. Yeah. Okay, if there are questions or comments, just interrupt me at any time or raise your hand. I'm not going to do that much talking today because today's Friday. You guys are going to do some active learning again. So today we're going to talk about dissertations. You're going to get a preview of what your future has in store for you. Right? We're going to talk about how to write those good dissertations. So it's not a requirement for your dissertations, but it is a nice thing if what you're working on is original or does something new, right, that nobody has done before. So it could be testing out a new idea, testing out an existing idea, but applying it to a new problem or a new scenario. A lot of papers combine two ideas together to try to unify and get the advantages of both. Of course, when you unify two solutions, there are always new disadvantages too, but you hope that the advantages outweigh the disadvantages. You might simply reorganize something that's existing. That can be a contribution. Or organizing something for the first time can also be something novel. Identifying flaws or overcoming limitations in existing knowledge. Applying new evidence to a well-known problem. Taking solutions from another field and introducing them to the world of computer science. That's very common, like mathematics. So a lot of research is based on mathematical theories that are then actually implemented in software. Or making a proof, like proving something is true. So you might be staring at this and still trying to wake up and thinking, how am I supposed to be able to identify what's new and what's not new? Well, there are multiple answers to that question. One answer is a literature review. So coursework 3 is a literature review. At the end of every research paper, there's a little bit of future work and still unsolved problems. So you can look there for unsolved problems. You can work on a good literature review that will help you identify unsolved problems. And a natural solution is also to talk to somebody that knows what they're doing, some member of staff, right? Members of staff will know about unsolved problems. All the members of staff are good at identifying unsolved problems and working on those. So good research is contextual. So if you think about it, what is a research paper? One of the defining characteristics of a research paper or a dissertation is the related work. you're summarizing the work that's been done previously on this topic. And that's one of the defining characteristics of a research paper. That is the research part in some ways. So it puts the current solution into context with the previous solutions. Good research is creative. How can we think of something new? That's a difficult question, right? How do we think of new things? That's not so easy to answer, actually. I think thinking of new things is a skill, actually. But certainly reading the previously published literature helps think of new things too. Right? It's not as difficult as it may seem, actually. A good literature review will also help you think of new problems to solve. A really good literature review. So good research is reproducible. So we mentioned reproducibility previously in a previous lecture, right? In the first day, actually, we talked about reproducibility. So good research is reproducible. The reader of your research understands and is convinced by how you arrived at your conclusions. Explain how you arrived at your results, which problems you had to tackle. Describe your project in enough detail that it can be reproduced by someone else. So this is the guiding principle for your writing in general. A lot of people ask me, oh, how much detail should I go into on this subject? It's just enough detail so that somebody else can reproduce it. Right? And the best research, you can reproduce the software that created the results, right? In that case, some researchers actually make their software available. Right? They'll check it into GitHub or GitLab, and then they will release the URL of their software so that other people can download it and run it and look at it and reproduce results. That's the best, like the gold standard, let's say, of research. Good research is ethical, moral, and benevolent. Good research ensures that it doesn't mislead or exploit people. I wish I could show this slide to every industry leader. It seems like the universities are good at talking about ethics, but then as soon as people graduate, the ethics just fly out the window. Anyways, I think that's pretty self-explanatory, right? Good research is often collaborative. So it's rare to work in isolation. You're usually working with other people, right? In your case, you're usually working with a supervisor, but you might be working with another academic in another department, like in mathematics, for example, or physics, right? In computer science, we're often collaborating with other disciplines. Could be biology, could be psychology, right? Because everybody needs software to help them solve their problems. You might be working with an external partner as well, like an industry partner. Some projects involve an industry partner, somebody outside the university. So it's rare that your research is done in complete isolation. It's very rare. Okay, everybody excited about today's workshop? This is today's task, active learning task. So we're going to look at dissertations today. There are 3 of them on Moodle. Right, we're going to form groups of 4 to 6. We're going to review Bob's guidelines. We're going to review the previous dissertations, both good and bad. Start a Google Doc. Identify and write 10 things that could be improved with the dissertation, right? 1 bullet point plus sentence for each thing you identify, and then share the Google Doc with me. I forgot to put in there, write your names too. Now before we jump in, review Bob's project guidelines. Let's do that now. I'm going to give you a little help with that. So as an added bonus to your education, I've written some guidelines about writing a dissertation. These are refereed guidelines or peer-reviewed guidelines. Does anybody remember what that term peer-reviewed means? Who can tell us what that means? Peer-reviewed. These are peer-reviewed guidelines. Does anybody remember what that means? Anybody?
Some other people in that field to check your paper.
That's right. So I wrote these guidelines. It took me 4 years, by the way. Not full time. I wrote these guidelines, and then I thought, why don't I publish them or try publishing them? So I submitted them to a journal. They went through a peer review process. That means reviewers, external anonymous reviewers, by the way. That's very important. Looked at them and approved them, and then the journal published them, right? And you can actually see, I know you're all really curious. By the way, one of the things you look for in a dissertation is, does it have a DOI? Anybody know what a DOI is? Who said something?
Date of issue.
It's a document object identifier, a DOI. That's not what you said, is it? So whenever you select a research paper, you want it to show the DOI. So look, you can see these. If you click on the DOI, you can see where they were published, right? And they've been viewed almost 18,000 times. I think this thing has oh yeah, look. If you don't want to read them, is that going to work?
Figures and data, references, citations,
Pretty cool, huh?
metrics, reprints and permissions, view PDF, abstract. These detailed guidelines attempt to explain the mechanics of writing a third-year project dissertation in computer science. They serve as a useful starting point for students and new advisors in their third or fourth year of study in the computer science department.
Pretty cool, huh? Anyway, so these are very detailed guidelines, and they have a very specific focus on the writing aspect of your dissertation, like how do you write the thing. So they go into a lot of detail, right? It starts with the abstract, like how do you write an abstract, right? There's a strategy for writing an abstract. And you might not know what that strategy is, but you can now look at that strategy and then try to follow it. And then there's a sample abstract there for you to look at that follows the guidelines that are given, right? And you can cite these guidelines. I recommend you cite these guidelines when you're using them. And look, there's a very detailed table of contents. This is the same organization you want to use in your dissertation as a starting point. You might be thinking, well, how do I organize my dissertation? Here is a starting point for your organization. You have an introduction section, right? It really should be called motivation. You have a background section. And in there you have a related work section, previous systems or similar applications, and then a subsection called data characteristics. You have a project specification section. You have a feature specification subsection, a technology choices subsection, a project plan and timetable, right? You have something like a Gantt chart that shows. By the way, there's advice in here. There's a lot of advice in here. You guys do not have an interim document. That's only for the enhanced MSc students. Right? So you won't have that. There's a chapter called Project Design that describes how your software or how your implementation or how your solution is organized. Then there's an implementation section, so how you actually carried out your work. A basic implementation section, these are must-have features, enhancements, commenting your code, coding conventions. There's a testing and evaluation section, right? How do you evaluate what you've done and that it's actually solving a problem or achieving the goal that you set out in the introduction. There's a conclusions, there's a future work section, and then there's a little bit about turning in your source code, acknowledgments, and appendix, and so on, and references. A lot of people ask me, like, how do I write references? Well, just look at Bob's project guidelines and you do the same thing, right? There are lots of references in Bob's project guidelines. Just do the same thing. I get that question a lot. And then I just say, look at Bob's project guidelines. There are references in there, right? That's how you do it. And then look, you might be wondering, how do I write the introduction? Well, here are very, very detailed guidelines, paragraph by paragraph, about what a good introduction looks like. What do you talk about in the introduction? How do you organize the introduction? Is there a certain kind of flow? The introduction has a certain flow, a good introduction, right? It really should not be called introduction, by the way. That's not a useful word. Unfortunately, that is the word that's used most often. It really should be called motivation. Why is this topic important? That's really what you're thinking about in the introduction. You want to convince the reader that what you're doing is relevant somehow and important somehow, right? That's what the introduction is really about. Here are the questions you want to answer in your introduction, some of the sample questions. It goes into a lot of detail about how to write your introduction. I'm not going to read the whole thing for you. I'm hoping that you're going to look at it today, actually, and when you're writing your dissertations. There's a subsection on formatting, right, how to format. There's a subsection on LaTeX. Has anybody here ever used LaTeX before? Nice, nice. It's not a requirement, it's just encouraged, yeah. There's even a subject on how to choose a good project title, right? Have you ever thought about how to choose a good title before? Probably not. Probably that's something you've never really considered. Then there's how to write the background section, right? You have a related work section. There's a subsection on citations, how to cite previous work, right? There's a subsection on previous systems or similar applications. That's where you describe software that's already, published that might be in use to many users, and that's similar to what you're working on. Right? You have a subsection called data characteristics. Usually your project involves some data, right? Some data as input to your project. Like maybe it's a data set you're studying, so you have a subsection called data characteristics that describes the data that you might be studying, right? Like in coursework 2. In coursework 2, you're going to see this. Then there's a project specification section. There's a feature specification, technology choices. Technology choices is about like what technology did you consider using for your solution? What technology did you end up using and why? Does it offer some advantages? What technology choices did you not use and why not? So you compare what you used and what you didn't use, and then explain why you chose the technology you chose, right? There's a project plan and timetable, right? I even have like a sample project timetable, like just the first 4 lines of what it could look like. Right? And then there's a time management, some advice on time management, some advice on proofreading. The interim document is only for the enhanced MSc students. How many enhanced MSc students do we have in here? Raise your hand if you're an enhanced. Okay, 2, 3, 4. Okay, good. So you might want to look at that interim document section. There's a section on design. I think a lot of you are probably not very familiar with this topic. If you're new to computer science, right, how to describe the design of your software, right, using diagrams, for example. Right, there are different kinds of design diagrams, and then it goes into detail about some of the common design diagrams, like process diagrams, system diagrams, class hierarchies, and so on, composition diagrams, and then it provides some examples of those. So that's a software system diagram. It talks about figures and images, how to include figures and images, what you can use to create figures and images. Look, there's a class hierarchy diagram. It talks about implementation, what you put in your implementation, some must-have features, enhancements or extensions. There's another design diagram. This is a composition diagram, it's called. Commenting your code, like your source code, you're expected to turn in a link to your source code on GitHub or GitLab. And this is some guidance on how to comment your code and also how to follow coding conventions when you do your implementation. Testing and evaluation. We're going to talk a lot about testing and evaluation in future lectures, actually, because that's huge. It's a huge topic. Results. How do you display your results, right, in your dissertation? Do you run a performance analysis? Is that what your target is, or are there some other aspects that you want to show? And then conclusions, future work, right? Turning in source code, acknowledgements, right? There's always an acknowledgement section. I have a little appendix there, and some references. So lots and lots of detail there, a lot. Like we could have a lecture easily just on Bob's project guidelines, but I don't think it's really necessary. What I don't want to deliver you a lecture on this. I want you to just give you a PDF that says, here you go, here are the guidelines. Use these when you need them, right, when it comes time to writing. Yeah. Any questions about that? So there's a copy of those on Moodle. And let's see. So we have a copy of those on Moodle, and then we have 3 dissertations on Moodle as well. Let's look at that. We have dissertation 1, it's a good example. We have dissertation 2, which is a good example. We have Bob's project guidelines, so you know how a good dissertation is organized. Question?
Yeah, sorry. Is there any specific format for us to reference, like Chicago or Harvard?
No, I think Harvard is fine. For your references, you mean?
Oh yeah.
Yeah, Harvard style is fine. Yep. And then there's a poor example. So the today's exercise is to look at the good examples in Bob's project guidelines and then the poor example, and then identify 10 things that can be improved with the poor example. Does that make sense? You write 10 things, one bullet point, so for each item that you think can be improved with a 1-sentence description. So you're writing 10 sentences, basically. Does that make sense? It's okay to write more than 1 sentence, but I would say 1 sentence is the target. You can write 2 sentences if you want to describe an improvement. And then you put that in a Google Doc with your names, and then you share the Google Doc with me, and then we'll go through them in the second half. Sound like fun? Try not to get out of control with your enthusiasm. Okay, I will go and recommend some groups now. Yeah. So group 5.
Thank you.